this was a game at the state fair, and they were charging $1 to play, and you get one spin. Would you play? Would it be a good deal? Yeah, $1's kind of a no-brainer. How about $10? Some people are saying, no, that's a little too expensive. How about $20? No way. Okay. So somewhere between $1 and $20 is a fair amount. It's the amount that you'd kind of expect to win if you played the game. And so that would be the fair amount. Like if it's a charity, they need to know what that fair amount is, because if they're a charity trying to play the game, they're going to try to make it so that they try to make a little money on this deal. So if the fair amount comes out to say $3.50, they're going to probably charge you $4 or maybe even $5 to play, so that they'll try to make money on you. Okay, that's just part of the deal. So we're going to calculate. First of all, I want you to guess. So I'm going to take a second here to have you guys guess. So how many of you think it's somewhere around $2? How about $3? How about $4? How about $5? So far I've only had a couple hands. Now at $5 I've got like 4 or 5 hands. How about $6? Got about 3 more people. How about $7-ish? Got another 3 or 4 people. How about $8-ish? Oh, there's like 5 or 6 of you. How about $9? $10? And there's one at 10. How about any more than 10? All right. So I'm not just going to tell you the answer. I'm going to tell you how you can figure out the answer. This is an expected value problem, and to do these, we always do this process. P times A, then add. So that you will remember that, please write that down. Okay, so I'm going to show you this one. P times A, then add. Well, there's 2 things that could happen. No, actually, there's 3. I could either get $1, or I could get $5, or I could get $20. And then I take the probability of each thing and multiply it by the amount that I will get, and then that will tell me my grand total. So P times A, then add. The probability of this $1 is 1/3. Well, in the $5, the probability is also 1/3. And the $20, the probability is also 1/3. So if I just take and multiply those out, would you please grab your calculator? You'll need it for homework today, later anyway. And just to get the answers quickly, I'll call on some different people. Let's see. Let's go with Mr. Williams for number 1. Let's go with Colin for number 2, the second part here. And let's go with Sam for the third one. Mr. Williams, what dollar amount would I get for this? Okay. 33 cents. How about for the second one, Colin? Is it 1.6? 1.67, $1.67. Okay, and for the third one, Sam? 6.66. You're driving around that to 6.67, I bet, right? And then, Sam, since you got that big number on your calculator, would you take that and add it to this and this? $8.66 is the expected amount. Now, can I even get that? Is that even a possibility on one spin? No, I'm going to either get 1, or I'm going to get 5, or I'm going to get 20. So it's important to understand what this is. This is like an average. If you played the game a whole bunch of times and figured out how much you won, that it would be an average of how much you had won, because you can't actually win $8.66. So that's the fair price that they should charge. At the state fair, they're going to actually charge you $8.66. Is it going to round $8.67? Okay, fine. We're off by a penny. That's okay. Yes? Mm-hmm. Yes, and we'll talk about that in just a second. But let's finish my question about this. $8.66 is the fair amount. Is that what they really charge at the state fair? Are they trying to be fair to you? No, they try to charge you money so that they can make money. So they realistically would charge about $10 to play a game like this. All right. Their games are more complicated to figure out because they involve some skill, like, you know, throwing a ball and knocking over some heavy things or whatever. So their games are a little different than this. Now somebody said, well, what I just did to get the answer was I took the amounts on the spinner, the 5 and the 1 and the 20, and I just added them all up and divided by 3. And that's a great way to do it, but only works in this kind of a situation because all the probabilities are the same. Yes, if you just take 20 and 5 and 1 and you average them, it comes out to $8.66. But that's not how you do it for any of the other problems, because when the probability wheel changes to look like this, that way it won't work anymore. You can't just add the 1 plus the 5 plus the 20 when it looks like this. So we got to use the method I just showed you. Now this is not really a spinner. It's just this green thing is a physical representation of what's in your wallet. Sounds like the commercial. And we've got 11 $1 bills, 4 $5 bills, and 1 $20 bill. What are you likely to get when you pull one of the bills out of that wallet? You're probably going to get a 1, right? But there's always that chance that you're going to get a 5 or that you're going to get a 20. All right? I'd like you to make a little tree for me for this one. There's 3 things that could happen. And then do probability times the amount, and then add them all up. I'll pause while you get those answers. So we wrote down all the things that could happen. Either you'd get 1, or you'd win 20, or you'd win 5. And there was 11 and 16 probability of getting a 1. The 20, there's only one of them out of 16. There is a $20 bill. And for the 5, the probability is there were 4 of them out of 16. And we actually multiply these all out. Okay, so we've got our probabilities times our amounts, and then the last part, then add them. Now we got to add up this and this and this, and we'll have our answer. It's $3 and something. $3.19. So again, you have to understand, this is an average. This is like if you went and tried this a bunch of times, what would likely average amount of money you'd get out of this. Because you're not going to actually get a $3.19 bill. It can't happen. But that's what you should kind of expect over time, and averages that would happen. All right, the next thing we're going to talk about is the iPod. If you were going to get one of these guys, they cost $149 nowadays, and they even shoot video. Kind of cool. Yep. That's just came out recently. It's the new Nano. And then there's the AppleCare plan, which if you want to buy it, is an optional insurance deal. It costs $39. Now, whether or not that's a good deal can be determined through expected values. So I'm going to show you one of those. I'm going to have to pause the tape to be able to make it fit. So there's 2 things that could happen. Either the iPod's going to break, and then say there's a 30% chance of that, or it's going to work, and then say there's a 70% chance of that. This is the probability. What did I say this expected value was again? Probability times the amount. An amount I get. Well, if I'm going to have my iPod work, I'm not going to get anything. In fact, I'm going to lose money. The amount I get is negative. Because why? If it keeps working and I bought the warranty, what did I lose? I lost $39 because I really didn't need to buy the warranty. Now, there might be some peace of mind, but all right. Then break. If it breaks, I do get something, though. What do I get? $149 worth of iPod back. And then I have to take away, though, the $39 because I got the warranty. Now, P times A, then add. We have to now add them all up. So let's do that. So once we got our P times A numbers, we just add them up. And this plus this adds up to this. If that comes out positive, we know that it was a good thing that we bought the warranty, because even factoring in the cost of the warranty, we have left over a positive 5. That means we made $5 on the deal. Now, does that mean I've just proved it's always a good idea to buy the warranty? No, depends. Depends on how much it costs. Depends on how much the thing is that you bought costs. We did this in a different hour, and we figured out that if you buy the expensive one, it's a really good idea to get the warranty. So, all right.